Hi guys, and today we will look into announcing TypeScript 5.4 by Daniel Rosenwasser at March 6, 2024. And they excited to announce the release TypeScript 5.4, and let's proceed to what's new. They preserve narrowing enclosures following last assignments. TS usually can figure out a more specific type for a variable based on checks that you might perform, and this process is called narrowing. And if we have a if statement and we have type of x equal to string, then TypeScript knows that x string is a string here. And one common pain point was these narrow types weren't always preserved as function closures. If we have function get URLs, and this function returns names that map with arrow function which accepts name, and that URL search params set name with name, and then we have your property search params does not exist a type string or URL. And if we have a if else statement, maybe it will be not near. So here TypeScript decided that it wasn't safe to assume that URL was actually a URL, which we now call back function, because it was mutated elsewhere. However, in this instance, that arrow function is always great after that assignment to URL, and it's also the last assignment to URL. But TypeScript 5.4 takes advantage of this to make narrowing a little smarter. When parameters and let variables are used in non-hoisted functions. Non-hoisted functions, it's a functions which declared, they use the term specification function, which means not return function, but function declaration, which includes var, let, const, so on. And the type checker will look up for a last assignment point. If one is found, TypeScript can safely narrow from outside the containing function. But it means it's about example just works now. Note that narrowing analysis doesn't kick in if the variable is assigned anywhere in a nested function. This is because there is no way to know for sure whether the function will be called later. So if we have this function and our value equal assigned to value, define value in a way that shouldn't affect its type, will invalidate type refinements in closures. And in an associate amount with console.log value, we have an error value is possibly undefined. Also, they add a known for utility type. So when calling generic functions, TS is able to infer type arguments from whatever you pass in. So if we have function do something with generic t type, with argument with t type, then we can explicitly say that t should be a string, and we can also just let the type of t get inferred. So it's the same. One challenge, however, is that it is not always clear what's the best type to infer. This might lead to TypeScript rejecting valid calls, accepting questionable calls, or just reporting worse error messages when it catches a bug. So, for example, let's imagine a create streetlight function that takes a list of car names along with an optional default color. So, we have function create streetlight with C type extends string. It's a shorthand for color, and we have colors double and default color C type, and there is no check. And here is also no check because blue isn't in this array. And in this call, type infers decided blue was just as valid of a type as red or yellow or green because blue is also string. And so instead of rejecting the call, TypeScript infers the type of C as red, yellow, green, blue. You might say that inference just blew up in our faces. One way people currently deal with is to add a separate type parameter that's bounded by the existing type parameter. So if we have a generic type of color extend string, and our D is default color extends our color, and we have two parameters, colors, a tuple of colors, and default color is with default color. It's also a color, but it's a color extended from string array of this. And as expected, we have an error because argument of type blue is not assignable to parameter of type red, yellow, or green or undefined. So interesting that that in this array we don't have a undefined string. This works, but it's a little bit awkward because T probably won't be used anywhere else in the signature for crested line. While not bad in this case, using type parameter only once in the signature is often a code smell. So I should say if it works good. If it works good, it is not a smell, it's just code. Only because of undefined here appears it a code smell. That's why the TS 5.4 introduced a new non-infer utility type. Surrounding the type with in non-infer utility type gives a signal to TS not to dig in and match against the inner types to find candidates for type inference. Using non-infer, we can write crested line as something like this. So C extend string colors with C tuple and default color with non-infer of C. That's cool. It has less code, same error, but also undefined string appears here, but we don't have undefined in this array. It will be very funny if your default color is undefined. Including the type of default color from being explored from inference means that blue never ends up as an inference candidate, and the type checker can reject it. Also, they introduced object group by and map group by. CS 5.4 adds decoration for JS new object group by and map group by static methods. Object group by takes an interval and a function that decides which group each element should be placed in. The function needs to make a key for each distinct group, and an object group by uses that key to make an object where every key maps to an array with the original element in it. So let's proceed to example. If we have const array of from 0 to 5, and we have a const my object, it's an object group by array, num and index, and return num divided by 2 equal 0, even and odd, and it transforms to my object even with this array and not with this array. Map group by is similar but produces a map instead of plain object. This might be more desirable if you need the guarantees of maps. You're dealing with APIs that expect maps, or you need to use any kind of key for grouping, not just keys that can be used as property names in JS. Yeah, it's pretty similar. We can notice that map group by also accepts array, a function, and say num divided by 2 equals 0 even odd, and it's similar to my object set even with this array and not with this array. So we should note that in the above example of object group by, the object produced uses optional properties. So we have interface even nodes. It's optional property even and optional property odd, and we have, and if we try to access of my object even, we have an error to access this under strict null checks. This is because there is no way to guarantee in a general way that all the keys were produced by group by. Note also that these methods are only accessible by configuring your target to use next or adjusting your lib settings. They expect they will eventually be available under a stable ES2024 target. Support for require calls in a -- model resolution bundler and -- model preserve. CS has a model resolution option called bundler that is meant to model the way modern bundlers figure out which file an import path refers to. One of the limitations of the option is that it had to be paired with -- model as next, making it impossible to use the import require syntax. So we have a previously errored import my model require model path. This might not seem like a big deal if you're planning on just writing standard yes imports, but there's a difference when using a package with conditional exports. In TS 5.4, require can now be used when accessing the model setting through a new option called preserve. Between -- model preserve and -- model resolution boundar, the two more accurately model what bounders and runtimes like bar will allow and how they will perform model lookups. In fact, when using -- model preserve, the boundar option will be implicitly set for -- model resolution, along with -- yes model interop and -- resolve JSON model. So if we have a model preserve, it also implies these properties to package JSON. I mean, yeah, should be or test config. Yeah, it should be test config. Yeah. Under -- model preserve, an ECMAScript import will always be emitted as is, and import with something require will be emitted as require call. Though in practice you may not even use TS for emit, since it's likely you'll be using a boundar for a code. This holds true regardless of the file extension of the contained file, so the output of this code is import all as full from some package full, and import bar requires some package bar. Should look something like this. Import all as full from package full, and variable bar equal requires some package bar. With this also means that the syntax you choose directs how conditional exports are matched. So in the above example, if the package JSON or some package looks like this, TS will resolve this path to MGS to full, and some package CGS bar from require CGS from require. Also, TS are checked import attributes and insertions, and import attributes and insertions are now checked against the global import attributes type. This means that runtimes can now more accurately describe the import attributes. And if we have an interface in some global file with first import attributes type JSON, and in some other model we have an import all as MS from full with type no JSON, we have an error because type not JSON is not assignable to type import attributes, and type not JSON is not assignable to type JSON. It should be the same types, I guess. And more interesting, they add a quick fix for adding missing parameters. TS now has a quick fix to add a new parameter to functions that are called with too many arguments. So, for example, if we have function with some functions and many parameters here, and VS Code can add missing parameters to some helper function, and add optional parameters to some helper function, but they not optional parameters. It's just missing parameters. And after that, it adds def and xyz to return some helper function. And this can be useful when threading the new arguments through several existing functions, which can be cumbersome today. So they add an auto import support for subpath imports. Node.js package JSON supports a feature called subpath imports via a field called imports. It's a way to remap paths inside our package to other model paths. Conceptually, this is pretty similar to path mapping, a feature that shorten model boundaries will support, and HTS supports via a feature called paths. The only difference is that subpath imports always have to start with a hash. TS auto imports feature previously did not consider path in imports, which could be frustrating. Instead, users might have to manually define path in the TS config. The JSON, however, Thanks to a contribution from Emma Hamilton, TS auto imports now support supply from imports. And we should also discuss current changes from TS 5.0 deprecations. TS 5 deprecates the following options and behaviors: char set, target is 3, so it should be done many years before. Imports not used as values, no implicit use strict, no strict generic checks, T of strings only, suppress excess property errors, suppress implicit any index errors, out, preserve value imports, depend in object references, and implicit or specific new line. To continue using them, developers using TS5 and other more recent versions have had to specify a new option called ignore deprecations, which is fun, with the value of 5.0. However, TypeScript 5.4 will be the last version in which this will continue to function as normal. By TS 5.5, likely June 2024, this will become hard errors and code using them will need to be migrated away. And also, we should discuss notable behavioral changes. These sections highlight a set of noteworthy changes that should be acknowledged and understood as part of any upgrade. Sometimes it will highlight deprecations, removals, and new restrictions. It can also contain bug fixes that are functionally improvements, but which can also affect an existing build-up by introducing new errors. So they libdts changes type generated for the DOM may have an impact on type checking for type checking your code base. For more information, see the DOM update for TS 5.4. Also, your more accurate conditional type constraints. The following call no longer allows a second variable declaration in the function foo. If we have type is array generic t extends any true false, and we have function foo which accepts u extends object and x is array type is array of u, and let first true equal assigned to x and let second false assigned to x. We have an error but previously wasn't. So it's quite interesting because first variable also produced an error, and the second variable didn't produce a new error, and it's interesting. Previously, when TS checked the initializer for a second, it needed to determine whether the array u was assignable to the unit type false, while is array u isn't compatible in any obvious way. TS looks at the constraint of the type as well. In a conditional type, like t extends for true branch, false branch, where t is generic, the type system will look at the constraint of t, substitute it in for t itself, and decide on uses the true or false branch. But this behavior wasn't accurate because it was otherwise eager. Even if the constraint of t isn't assignable to foo, that doesn't mean that it won't be instantiated with something that is. And so the more correct behavior is to produce a union type for the constraint of the conditional type, in cases where it can be proven that t never or always extends foo. More aggressive reduction of intersections between type variables and primitives types. TS now reduces intersections with type variables and primitives more aggressively, depending on how the type variable constraint overlaps with those primitives. If we declare function intersect which accepts t and u, x with type t and u, and y is with type u, and intersection of t and u in returns. So if we have function t extends abc, union of def and abc and def strings, and our x is a type of t, string type of string, and num of number, and we have a interface, let a interface x and string. It was intersection of t and string, and now it's just t, and we have a let b intersect of x and num. It was t and num intersection, but now just never. And if we have let's see math random less than 0.5, we have intersect x of ABC and intersect x and def. And it was a union and union between two intersections of T and ABC and T and def string, and now just type T. And they improve checking against template strings using interpolations. TS now more accurately checks whether or not strings are assignable to the placeholder source or template string type. So if we have function a with t extends id string, and we have let x this type of template string starting with dash, key of t intersection of string, it produces an error, and now it doesn't. This behavior is more desirable but may cause breaks in code using constructs like conditional types, where these rule changes are easy to witness. Also, errors when type only imports conflict with the local values. So previously TS would permit the following code under isolated models if the import to something only referred to a type. So if we import something from some path and let something similar to our import, however, it's not safe for single file compilers to assume whether it's safe to drop the import even if the code is guaranteed to fail at runtime. In TS 5.4, this code will trigger an error like the following. Import something conflicts with local values and must be declared with a type-only import when isolated models is enabled. It's good. The fix should be to either make a local rename or the error states in the type modifier to the import. If we import type something from some path, or import type something from some path. Also, they add new enum assignability restrictions. When two enums have the same declared names and enum member names, they were previously always considered compatible. However, when the values were known, TS would silently allow them to have different values. TS 5.4 tightens these restrictions by requiring the values to be identical when they are known. If we have namespace first and second with export enum some enum, AB01, AB02, if we have function with x of type first some enum and y second that enum some enum, both used to be compatible, no longer the case. And TS errors with something like each declaration of some enum that b differs in its value range. String of 1 was expected while string of 2 was given. Additionally, there are new restrictions for when one of the enum members does not have a statically known value. In these cases, the other enum must at least be implicitly numeric, e.g. it has no statically resolved initializer, or it's explicitly numeric, meaning TS could resolve the value to something numeric. Practically speaking, what this means is that string enum members are only ever compatible with the other string enums of the same value. So if we have a space first export declare enum some enum, and a space second export declare enum some enum, but b is a string, both used to compatible with no longer the case. TS errors with something like one value of some enum that b is a string with string value, and the other is assumed to be an unknown numeric value. And we have a name restrictions on enum members. TS no longer allows enum members to use the names infinity, minus infinity, or not a number. Here is a none of this. An enum member cannot have a numeric name, enum infinity 0, minus infinity, none. So if someone named your enum with these variables, I hope you are a genius. And also they add better map type preservation over tuples with inherent dependency. Previously, applying a map type with any into a tuple would create an any element type. This is undesirable and is now fixed. So if we have a promise all of an array and starting with empty rest, and we have a type of empty array as any, and then result an empty function, and we have const head is our result of 0, and const tail result assigned to result size 1. And we have a difference in 5.3 it was any, and in 5.4 it's a string because the result 0 it's a string, and 5.4 it's any because it's a rest of our promises and it's any array. Any changes for not a break and change per se, developers may have implicit taken dependencies in GS, or declaration input outputs. The following are notable changes. Reserve type parameter names more often when shadowed, more complex parameter lists of a single function into down level generator body. The method will be binding others in function declarations, and import attributes will go through the same emit phases when in an import type node. And thanks for watching. Bye.